Hi my dear students, welcome back to the class. So far we were discussing about relations and functions, and we discussed the Cartesian product of any two finite sets, and we discussed what is an ordered pair, ordered triplet, the condition for an ordered triplet and ordered pairs to be equal. In this session we are going to solve exercise 2.1. So without any further intro, we shall directly move on to the exercise questions. Coming on to the first question, the question is that if x by 3, ordered pair x by 3 plus 1 comma y minus 2 by 3 is equal to ordered pair 5 by 3 1 by 3, we have to find the values of x and y. We know that whenever we are given with two ordered pairs, the ordered pairs are equal only if the corresponding elements in the ordered pairs are equal. That is, first element in the first ordered pair must be equal to first element in the second ordered pair. Similarly, second element in the first ordered pair must be equal to second element in the second ordered pair, so that the equality of the ordered pairs gives us that x by 3 plus 1 must be is equal to 5 by 3 and y minus 2 by 3 must be is equal to 1 by 3. Now we can simplify these two relations in order to get the values of x and y, isn't it? So from this we have x by 3 is equal to 5 by 3 minus 1 and y is equal to 1 by 3 plus 2 by 3, which implies x by 3 is equal to, what is this? We can take the LCM and substitution gives 2 by 3 and this gives 3 by 3, and this will gives, we have to find x, so that this 3 will go to the numerator. So it is equal to 2 by 3 into 3 and y is equal to 3 by 3 is nothing but 1. 2 by 3 into 3, which gives us x is equal to 2 and y is equal to 1. So this is the answer for the first question. Coming on to the second question, the question is that if the set A has 3 elements, so number of elements in the first set is nothing but what? 3. And the set B is equal to 3, 4, 5. Hence it is easily observable that the number of elements in the second set is nothing but again 3. Then we have to find the number of elements in A cross B. We know that whenever the number of elements in A is P and number of elements in B is Q, then we know that number of elements in A cross B is nothing but what? PQ. That means number of elements in A cross B in this case is nothing but 3 into 3 is equal to 9, which is the answer of the second question. Coming on to the third question, the question is that if G is equal to 7, 8, set 7, 8 and H is equal to set 5, 4, 2, then we have to find G cross H and H cross G. It's very simple. We know that G cross H is the set of all ordered pairs where the first element must come from G and the second element must come from H. We know that G cross H is nothing but, we can make the ordered pairs fixing the first element as 7 and varying all these elements we get 7, 5, 7, 4 and 7, 2. Again, fixing the first element as 8 and varying all the elements we get 8, 5, 8, 4 and 8, 2 as a set of all ordered pairs in G cross H. Now coming on to H cross G. In H cross G we know that the first element must come from H and the second element must come from G. Then we have ordered pairs 5, 7 and 5, 8 as the first ordered pairs, then 4, 7 and 4, 8 as the second elements, then we have 2, 7 and 2, 8 are the last two ordered pairs. See, here we constructed G cross H and H cross G. Also note that 7, 5 is not equal to 5, 7. Hence these two sets are never equal, not equal. That's also to be noted. So H cross G need not be is equal to G cross H. Coming on to the question number 4, we have to identify the false or true statements from the given set of statements. If it is false, we have to rewrite the original statement to a true statement. Okay, the first statement is that if P is equal to set of all m comma n and Q is equal to set of all n comma m, then we have to find out P cross Q, given that P cross Q is equal to set of all ordered pairs mn and nm. We know that whenever a set P contains 2 elements and Q contains 2 elements, then we know that P cross Q must contain 4 elements. Hence, we can easily identify that this statement is a false statement, and we can rewrite this statement into a true statement as. Note that the first statement is a false statement, and we are going to rewrite the first statement into a true statement as P cross Q is the set m comma n comma m and n comma n comma m. So this is the true statement corresponding to the first given statement. Coming on to the second statement, we are given with if A and B are non-empty sets, then A cross B is a non-empty set of ordered pairs xy such that x element of A and y element of B. We know that whenever we are given with two sets A and B, then A cross B will definitely the set which contains all the ordered pairs, where the first element comes from the first set and the second one comes from the second set. Hence, definitely the second statement is true as it is given. Now coming on to the third one. If A is equal to 1, 2 and B is equal to 1, 3, 4, then A cross B intersection phi is equal to phi. We know that any set intersection phi will be phi, and we know that A cross null set will definitely phi. So this given statement is true as it is given. So the first statement was the only wrong statement, and we corrected that statement, and the rest two statements are true as given it is. Coming on to the fifth question, the question is that if A is equal to set -1 comma 1, find A cross A. We know that A cross A is a set of all triplets, where the first one comes from A, second one comes from A, and third one comes from A. Let us check what is A cross A. A cross A is equal to set of all ordered triplets. First I am fixing -1 in the first place, and again I am fixing -1 in the second place and -1 in the third place also. So I got the first order triplet. Now -1 in the first place, -1 in the second place, and I am changing this -1 to 1. So I got the next order triplet. Now I am again making the triplet by changing the second one. -1, 1, -1, -1, 1, 1 as the next two triplets. Now I am going to change the first element in each triplet. Then it will get -1, 1, -1, -1, and 1, -1, 1, and 1, 1, -1, and that the last I got 1, 1, 1. So this will be the set of all ordered triplets where A is the set -1, 1. So I got how many elements? 1, 2, 3, 4, 5, 6, 7, 8. See, A contains 2 elements. So A cross A will contain 2 into 2 elements. So that will be 8. So our answer is correct. So in this way you can check whether your answer is correct or not. Coming on to the sixth question, the question is that if A cross B is given as set of all ordered pairs AX, AY, BX and BY, find A and B. We know that whenever we are given with two sets A and B, A cross B contains all the ordered pairs from the first element is from the first set A and the second element is from the second set B of each ordered pair. Or suppose that if we are given with two sets A and B and we are supposed to find B cross A, then for each ordered pair the first element will come from the set B, which is B, because B occurs first in B cross A, isn't it? Similarly, the second element will come from A in each and every ordered pair. Similarly, this set also contains first elements from the first set and the second elements is from the second set. So, we can easily construct the set A as set A comma B and the set B as set X comma Y. Also, you can easily observe that since A cross B contains only 4 elements, then the possibility for the number of elements in A and B will be either 2 into 2 or 4 into 1. So, you can easily observe these two things from the given question and you can easily construct A and B. Coming on to the 7th question, the question is that let A is equal to set 1, 2, B is equal to set 1, 2, 3, 4, C is equal to set 5, 6 and D is equal to set 5, 6, 7, 8. Verify that. We have to verify these two conditions. In order to verify these two conditions, it is enough to prove or check whether LHS is equal to RHS. Coming on to the first one, we can see B intersection C. See, there is no element common in B and C, therefore B intersection C will be 5. Therefore, A cross B intersection C is equal to A cross 5. It is equal to 5. So, the LHS of the first given statement is 5. Now, coming on to the RHS of it, we can see that A cross B is equal to set of all ordered pairs 1, 1, 1, 2, 1, 3, 1, 4, isn't it? Now, 2, 1, 2, 2, 2, 3 and 2, 4. So, this is the set A cross B. Now, we shall find the second one A cross C. So, A cross C is equal to the set 1, 5, 1, 6, 2, 5, 2, 6. So, this is the set A cross C. You can see that there is no element common to A cross B and A cross C. Therefore, A cross B intersection A cross C is equal to 5. Therefore, LHS is equal to RHS. Therefore, the first one is verified. Now, coming on to the second one. We can find A cross C at the first. We have to check A cross C is a subset of B cross D. So, we have to find A cross C as well as B cross D. A cross C is equal to A cross C is already found out here. So, it is nothing but set of all 1, 5, 1, 6, 2, 5 and 2, 6. So, this is the set A cross C. Now, B cross D is equal to, see, B cross D is a big set. It contains 4 elements. So, B cross D will contain 16 elements. We shall evaluate that 1, 5, 1, 6, 1, 7, 1, 8, 2, 5, 2, 6, 2, 7, 2, 8, 3, 5, 3, 6, 3, 7, 3, 8, 4, 5, 4, 6, 4, 7 and 4, 8. So, there will be 16 elements in B cross D and you can see that 1, 5 is an element of B cross D, 1, 6 is an element of B cross D, 2, 5 is an element of B cross D and at the last 2, 6 is an element of the B cross D. Therefore, A cross C will be a subset of B cross D and the second statement is also verified. Coming on to the 8th question, the question is that let A is equal to set 1, 2 and B is equal to set 3, 4. How many subsets will A cross B have and list them? We know that A cross B can be easily evaluated as A cross B is a set 1, 3, 1, 4, 2, 3, and at the last 2 4. So this is the set A cross B. How many subsets will A cross B have? We know that A cross B now have how many elements? 4 elements. Therefore, we know that whenever I set A has m elements, number of subsets or number of elements in the power set will be 2 raised to m. Number of elements in the power sets means number of subsets of A, isn't it? Because power sets contain all the subset. So 2 raised to m. Here n of A cross B is nothing but what? 4. Therefore, number of subsets equal to 2 raised to 4 is equal to 16. Now we shall list each and every subset. We know that for any subsets are, we know that for any set 5 will be a set. Now 5 will be a subset of it. Now we know that this contains 4 elements. Each singleton will be a subset of the set. So singleton set 1 3, singleton set 1 4, singleton set 2 3, singleton set 2 4 are all subset. Now we can associate each 2 pairs to get new subset. So set 1 3 and 1 4 will be a subset of the original set. Set 1 3 and 2 3 will be a subset of the original set. Set 1 3 and 2 4 will be a subset of the original set. Again, set 1 4 and 2 3 will be a subset of the original set. Set 1 4 and 2 4 will be a subset of the original set. Again, set 2 3 and 2 4 will be a subset of the original set. Now we already enquired all the pairs or all the couples from each ordered pair, each element of the set. So we can have the subsets like this containing 2 elements each. Now we are going to generate subsets containing 3 elements each. So first element will be this one. Set ordered pair 1 3 comma 1 4 comma 2 3. So the first 3 elements of the first subset is this. Now coming to the next, ordered pair 1 3 1 4 2 4, 1 4 2 4 like this. The next one will be, so we had this one a set, this one and this one a set. Now we are going to make this one and this one as another subset. So it will become 1 4 2 3 and 2 4. Now we are going to make this one and this one as the subset. So it will become 2 3 2 4 and finally we have 1 3. So we already enquired all the possible 3 element subset from A cross B. Now we are going to find the entire set. We know that whenever we are given with entire set, the entire set will be a subset of the set itself. So we have the set as 1 4 1 3 1 4 2 3 and 2 4 as the subset of the original set. So we have 16 subsets of the original set A cross B. Coming on to the 9th question, the question is that let A and B two sets such that number of elements in A is equal to 3, number of elements in B is equal to 2. Now if ordered pair x1, y2 and z1 are in A cross B, find A and B where x, y and z are distinct element. We are given with n of A is equal to 3, which means that A contains only 3 elements. See, the first elements are from A and x, y, z are 3 distinct elements. Hence we can say that A only contains these 3 elements x, y and z. Now n of B is equal to 2, which means that number of elements in the set B is equal to 2, and we know that whenever we are given with ordered pairs, the second elements are from the second set, and 1 2 are 2 distinct elements from B, and B contains only 2 elements, which means that B is the set 1, 2. So that's the question number 9. Coming on to the 9th question, the Cartesian product of A cross A has 9 elements among which are found minus 1, 0 and 0, 1. So among the 9 elements we are given with only 2 elements, minus 1, 0 and 0, 1. Find the set A and the remaining elements of A cross A. It's a very simple question. See here, minus 1, 0 and 0, 1 are element of A cross A. So we have minus 1, 0 is an element of A cross A. 0, 1 is also an element of A cross A. Since the first element comes from the first set and the second element comes from the second set, we can say that minus 1 is an element of A and 0 is an element of A, since A cross A is considered here. And here also we have 0 is an element of A and 1 is an element of A. Therefore, minus 1, 0, 1 elements of A. Also given has that A cross A has only 9 elements. We know that whenever A has m elements and B has n elements, A cross B has mn elements. Now since A cross A must contain A cross A must contain 9 elements, and we are given that A must contain 3 elements. Why? Because whenever A contains 3 elements, this also contains 3 elements, which result in 9 elements. Suppose that A contains 9 elements, this must contain 9 elements. In A, since we are considering A cross A and both the sets must contain equal number of elements. So the only possibility for the number of elements in A is 3 and 3 to get 9. So number of elements in A is 3 and we already have a 3 elements in A. Therefore A is the set minus 1, 0 and 1. Therefore we can easily find out the full set A cross A as A is equal to minus 1, 0, 1. I am writing it again in order to easily find the cross product of the two sets. So we will get minus 1, minus 1, minus 1, 0, minus 1, 1. Now 0, minus 1, 0, 0, 0, 1. Again 1, minus 1, 1, 0 and 1, 1. This will be the 9 elements of A cross A, and that's the end of exercise number 2.1. and I hope this is a very simple exercise, I know, and I hope you understood this very clearly. Now we shall move to the definition and properties of relations in the next class. Stay tuned for the next class.